Hi, this is All the Science, the science podcast that describes an interesting aspect of science in 5 minutes or less. I'm Waasay, and I'm the guest podcaster for this episode on the physics behind basketball. Basketball, the sport in which you throw a round ball into a hoop. We all see the likes of Steph Curry, Kevin Durant, James Harden, and Paul George shooting the ball from far distances that are beyond imaginable. These distances can be from the three-point line and occasionally the half-court miracle shot at the end of a quarter. But when shooting from such a distance, what is required to make such a shot? That is what I will be digging into in today's episode. When I was searching for what is required to make a shot into a basketball hoop, I thought we must first look at the dimensions of a basketball hoop and the basketball itself. The hoop is 10 feet above the ground, with the backboards being 72 inches wide and 42 inches tall, and the basketball rims are 18 inches in diameter. A men's basketball has a diameter between 9.43 inches to 9.5 inches, while a women's basketball has a diameter of 9.07 inches to 9.23 inches. The reason for the range in size of a basketball is due to the overinflation of a ball or the underinflation of a ball. I'll be looking at 3 types of shots that are taken in a game of basketball: a simple layup, a free throw line jump shot, and the 3-point shot. A layup is usually taken from 2 to 4 feet away from the rim, a free throw line jump shot is 15 feet from the rim, and a 3-point shot is 22 feet from the corners and 23.75 feet from the top. This is important to know because the further away you are from the rim, the less angle of trajectory required for the ball to go in, or the closer you are to the rim, the more angle of trajectory is required to make the shot. Now we can get into the fun stuff. The physics behind these specific shots. Newton's third law states that with every reaction, there is an equal and opposite reaction, just like your guys' applause and your boos. This same law is applied to shooting a basketball. When shooting, there's a force applied by the ball on your hand and a force applied by your hand on the ball. The ball will experience its backspin from the friction between our hand and the ball. Backspin is important because the spin leads to the ball losing more energy on its bounce, making it more likely to go into the rim. When looking at the physics and numbers behind shooting, we all must realize there are changing factors that affect the conditions we must reach to succeed at shooting the ball. Standing reach is one of those factors. The higher the release height can mean you need a lower angle of trajectory to make a shot, and vice versa. The lower the standing reach can mean you need a higher angle of trajectory to make a shot. For the sake of this episode, I will use a release point of 8 feet above the ground. Angle of trajectory can lead to a higher chance of making a shot because it creates a better arc. A higher arc means you have a bigger target when the ball reaches the rim. As stated before, the rim has a diameter of 18 inches and a basketball is right around 9.5 inches. So in theory, you should almost be able to fit 2 basketballs through one rim. If the ball is placed at the center of the rim, that gives you 4.5 inches from each side of the ball to the rim. This would be an ideal shot as it leaves 0% chance of missing. 4.5 inches from each side of the rim leaves a good amount of room for the ball to shift over and still head through the rim. This is why our angle of trajectory can be different by a few degrees, and the ball will still make it through the hoop. If releasing from 8 feet above the ground from layup range, it would require 72 degrees to give yourself the best chance to make the shot. When shooting a 3-pointer, it would require 45 to 48 degrees of an angle of trajectory, and from the free throw line, it would require around 51 degrees for it to go through the hoop. The launch speed of the ball will also be a factor in allowing the ball to reach the rim and have the perfect trajectory. Force equals to mass times acceleration. This means force is proportional to mass and acceleration. Therefore, more acceleration means more mass means more force, and more force means more acceleration. Research has shown that from 2 feet, a speed of 10 miles per hour is required to get the ball to the hoop and at its preferred trajectory to make the shot. From the three-point line, 18 miles per hour is required. The further you go from the rim, the more force is required on the ball to get to its preferred speed. This concludes our episode of All the Science, the Physics Behind Basketball. Thanks for listening, and feel free to contact us at allthescience@gmail.com.